This sequence detector, okay, this sequence detector is a sequential circuit, okay, which is used to find the sequence in many bits what you are having. Okay, for example, if you have 1,000 bits of information like 1001 something like that, if you want to find your desired sequence, we can use this sequence detector in order to find the sequence, how many times that sequence is present, and wherever the sequence is present can be detected using your sequence detector circuit what you are going to design. And here, when you're trying to design a sequence detector, students, we need to consider two things. One is overlapping, and or whether we are allowing overlapping or not allowing overlapping. That should be understood. Okay, let me explain you what is meant by overlapping and not allowing this overlapping. Students, let me take any sequence. Let me take a sequence like this. Okay, so for example, my sequence is 101 something like this. I have taken a sequence, and my desired sequence is, okay, so I'm trying to design a sequence, sorry, sequence detector to find the sequence 101, for example. Look at here, students. I have 101 in here, so that is my desired sequence. And if I go on from there, I don't find any sequence like that. And again, I can see one more sequence in here, 101. And if I go moreover, there are no 101 sequences I can find. This is the way how I have to find a sequence 101 if overlapping is not allowed. If overlapping is not allowed, I can see 101, and I have searched for many bits for getting one more 101, and here I can see one more 101 is available. Then if I go anywhere else, I cannot find any one more 101 anymore. This is the case when we can find 101 when overlapping is not allowed. If I take the same sequence to design a sequence detector with overlapping is allowed, look at here how I can find the 101s. Same, I'm trying to see 101s in here. So I can see 101 sequence here, desired sequence. And I have searched here, is there any chance of having 101? So here there is 101. And here, after finishing this 101 in here, okay, this 101, I can take the last bit of this completed sequence as the first bit of next 101, like this. Okay, there is overlapping in between these two 101s. Okay, this is the way we should consider overlapping if you're trying to have overlapping in your design of sequence detector, students. If overlapping is not allowed, there will be only 101. There will be only one 101 available in here. If overlapping is allowed by us in the design part, then this 101 is considered as one of the desired sequence, and the last bit of this 101 is considered for your next 101, first bit of next 101. This is called allowing of overlapping in the design of a sequence detector, students. Okay, let me explain you how we can design a sequence detector with the help of Mealy state machine, for example. Okay, students, let me take, I'm trying to design a sequence detector for the sequence 101, for example, for the sequence 101, and I'm trying to allow overlapping here. I'm trying to allow overlapping in here. If overlapping is allowed and if overlapping is not allowed also, if you're trying to find a sequence of 101, for that we definitely need three states, because there is 3 bits of information is to be found 101. For example, if I'm trying to find 4 bits of information in the design of state machine, definitely you need four states to design that. Since I have 3 bits of information here for this designing a sequence detector for 101, I definitely need 3 states here. Let me assume that my states are state A, and state B, and state C here. Okay. So what is the job of these three states? What we have A, B, C. The job of state A is to detect the bit 1. The job of the state B is to detect bit 0. The job of the state C is to detect the bit 1 in here. Okay, that is the job of each state that I'm assigning. Now, let me assume that I'm having a sequence, students, with 1,000 bits of information I'm having. In that, I'm trying to design a sequence detector by allowing my overlapping here to detect the sequence 101 now. Now, I told you what is the job of each state I'm having in here. Students, listen to this carefully. If I'm trying to pass through a bits of information, a sequence of information, and if I find a bit 0, for example, initially, okay, if I find a bit 0 initially, whether the job of the state A is finished or not. If I
No,
find
sir.
no, what is the job of state A actually? It has to find a bit 1.
One, sir.
So
One, sir.
if a state is finding a bit 0, its job is not over, such that it will come back again to the same state. Okay, the sequence, if I'm finding a bit 0, for example, that is not our desired bit, desired first bit, so it will stay in the same state with an output 0. And here, students, one more thing I should definitely explain you about is output. The output of this sequence detector will be 1 after finding the entire sequence 101. In the sequence, whenever I find the entire sequence 101, then only the output will be decided as 1. For remaining all cases, your output will be 0. Okay, so when I'm there in the state A, in order to find my first bit 1, I found initially 0. So your job of state A is not over, so that I'm staying back at the same state in order to detect the initial bit 1. Now students, I have found my initial bit 1 now. Okay, I found the bit 1 now. So now can I say the job of state A is over, since that is my first bit in the desired sequence?
Yes, sir.
Yeah,
Yes, sir.
so when I found an input 1, when I'm there in the state A, the job of state A is over, so I can definitely move to the state B now. I can move to the state B. So when I'm finding an input 1, when I'm there in the state A, and also I am producing an output. What output will produce here, students?
0, sir.
0, sir.
0. Yeah, 0 and placing. So your in the information 101, your first bit is completed, means state A is over, students. Now let me go for finding my second desired bit. What is the second bit we need? That is 0 here.
0, sir.
Yeah, that should be found out by using the state B here. Now if I find a state B, if I find an input 1 in here, for example, okay, actually my desired input sequence input bit is 0 actually, sorry, but if I find 1, what will happen? Since that is not my desired bit, it will stay back in the same state with an input with an output 0 here. Okay, then what is the possibility, other possibility, students? If I find 0, since that is my desired sequence for the second state, the job of the second state is over when it is finding an input 0 here. So you'll be moving from state B to state C now, since your state B has to find 0 only. Now students, your 1 and 0 is found out, which is over. Now we have only one more pending bit. What is that, students, in our desired sequence? 1. Okay, 1. That should be found out using your state C here. Now you have to think carefully. There are two possibilities we have. If C is finding 1, your sequence will be over. If state C is finding bit 0, your sequence will become already 1, 0 is already found out using state A and B. If 1 is found out, your sequence is completely over. You can generate an output 1 in here. If your state C is generating an input, finding an input sequence 0, your entire sequence is wrong, students. Okay, since we need 101, we found out 100. So entire sequence is wrong. That is the possibility here. Now let me think. If I am finding 0, for example, okay, from the state C, since you already found out 1, 0 using state A and B, if state C is finding a bit of information 0, your sequence is becoming 100. Students, tell me, do you need the sequence 100? Is that is your desired sequence?
No, sir.
No. So what happened? The entire 3 bits are wrong. We need 101, but we found 100. So 3 bits of information what we found is entirely wrong. If you are finding 101, that is true and right. Your sequence is found out. But you are finding 100 by finding 0 in the state C. So when the 3 bits of information is over, you need to have 3 more states. We need to have 3 more states in order to find 101 again. Is it right, students? When you are finding 100, 3 bits of information is wrong. Now, if you want to find 101, again the next 3 bits, again how many states we need for that? For finding 101, how many states we need, students, for finding 101? 3 states are needed.
3,
Okay,
sir.
3 states. That's why if I am finding 0, okay, in the state C, I will go to the state A now. Okay, if I am finding an input 0, since the entire information 3 bits are wrong, I will go to the initial state since I want to find 101 again, and with an output 0 here. Students, are you clear? Why am I moving from state C to state A when I'm finding 0? Are you all clear?
Yes, sir.
Yeah. See, if I find 101, 3 bits are wrong. If 101 is, that is exactly right, students. Your job is over. But if I'm finding 100, 3 bits of information is wrong. So you have to find 101. For that 101, you need 3 new more states. For that, A, B, C will be utilized again. That's why from C, I'm moving to the state A now. That is one case. Now 10 is found out using state A and B, and state C, if it is finding 1. Tell me, students, whether your sequence is completed or not.
Completed, sir.
Completed. So what will happen? What will happen if I'm giving if state C is finding a bit of information 1, your entire sequence, desired sequence 101 is completed and found out, and it can generate an output 1 here. Okay, it can generate an output 1 here. The job of 3 states A, B, C is completely over, and you can end that sequence 101. You can move on. But where the sequence detector has to move, if the state C is found out any bit 1, where that has to move. Listen to this carefully, students. When I'm finding 1 using the state C, I can move to the state B now. When input is 1, your 101 is over. Since 101 is completely found out, I can generate an output 1 in here. Students, let me explain you why should I move from state C to state B here. State C to state B here. Since your 101 is found out, you can ask me, sir, 3 bits of information is over. Then if I want to find 3 more bits like another 101, I need 3 more states. For that, I should move to the state A. Why you are moving to the state B? Okay, that is your that may be the doubt you may have, students. Students, when I started explaining about this concept, I told you I'm allowing overlapping here. Okay, I told you I'm trying to design a sequence detector which allows overlapping. Overlapping, I explained you already. So like this, if I have 101, 01, a sequence like this, okay, 101 and 01 here. If I have a sequence like this, this is 101. Okay, you found out. But this last bit of this 101 can become first bit of next 101 by allowing overlapping here. Okay, this one is shared by 2 101s. And here when overlapping is allowed, students, this one, what I'm finding, okay, 101 is found out. Okay, this one, which is found out with the help of state C, may be the first bit of next 2 bits 101. That is a possibility, students. Okay, so I already found out 101 using 3 bits. This is completely over, students. 101 is completed. But this one which is found out with the help of state C, this one can be the first bit of next 2 bits. Okay, so if overlapping is allowed, students, if this is the first bit of next 101, how many more bits needed for finding 101? How many more states are needed?
2 bits.
2 bits. So 2 states, not 2 bits, 2 states are needed. Let me think that the state B and C are used for that. Okay, if state C is finding 1, we need 2 more states for finding 0 and 1. In such a case, I will be moving to the state B here. I'll be moving to the state B here to find 0 and 1 again. So I'm moving from state A to state B here, students. Students, not only this case, if they're giving any other sequence like 1 0 1 1 or any other sequence, maybe for overlapping and may not be allowing their overlapping, you should be able in a position to design a state diagram. If you have designed the state diagram in exact way, can you hear my voice now?
Yes, sir.
Yeah.
Audible.
Okay, so somehow I lost my internet connections. Okay, let us come back again, students. So we have designed a sequence detector. Okay, we have designed a sequence detector for detecting the sequence 101. Not only this sequence, students, they may give you any sequence like 1011 or 110. They may give you any sequence, and they may ask you to design a sequence detector by allowing overlapping or by not allowing the overlapping. That may be a choice of their design. So if they are asking something like that, you should be able in a position to design your state diagram. If you have designed the state diagram in a proper way, then the rest of the design part will go in smooth way. Okay, if your state diagram is exactly right. Okay, then let me explain you, students, how this design part is carried out with the help of this presentation. Let me show you how this sequence detector is designed with the help of the state diagram. So here, students, you can see the state diagram, what I have designed for 101. Now you can see what are the present states that are available in this state diagram I'm showing here, and what are the next states that are available, and what are the outputs you are generating. Look at here, students, what are the states I'm having in here in this state diagram? What are the states available in this state diagram? A, B, and C. These are the A, B, C are three present states I have. Okay. Then what are the next states I can get with the help of inputs? Look at here, students. If I'm there in the state A, if I give an input 0, where I'm moving? If I'm there in the state A, if I give an input 0, where am I moving?
Same state, sir.
Same state. So when I'm there in the state A, when input 0 is given, I'm there in the same state. When I'm there in the state A, if I give an input 1, where am I moving, students?
B, sir.
B. So from A with an input 1, I'm moving to the state B. At that time, I have shown you what are my outputs. When x is equal to 0, when I'm there in the state A, I'm producing an output 0. When x is equal to 1, I'm producing an output 0 here. That is happening. Okay. The same conditions they have explained for state B and state C also. When input 1 is given, when input 0 is given, where am I moving, and what are the outputs you are generating is mentioned here with the help of state diagram what I'm having here, students. Okay. And also here you can see if I have 3 bits of information like A, B, C, they are denoting them like 0 0 0 1 1 0, students. Okay, 0 0 0 1 1 0 are the 3 states they are considering with A and B. And wherever I can see A, they have considered 0 0. Wherever I have seen B, they are considering 1 0. Wherever I see state C, they are considering 1 1 1 0 in the place of state C here. That is what they have taken. Okay, then for that we need to go for K-map simplification for state A, for state B, and for state Z, nothing but output. So you can get output by using these values, students. Okay, there are 6 values available here. You can take 2 more, don't cares. And for A, you can see 6 values, 2 more don't cares can be taken. For state B also you can see 6 values. Okay, these are 0 0 0 1 1 are the values you need to consider for designing input B here. Okay, so consider those values with 2 more don't cares in the K-map. Okay, with 2 more don't cares, you design what is the value you can get for A, what is the value you can get for B, and what is the value you can get for output Z. So when I'm designing a K-map, I got Z is equal to AX. So Z is equal to A into X is designed here, students. And when I'm trying to design a sequence detector with the help of this D flip-flop, since I'm designing for 2 bits of information 0 0 0 1 1 0, I'm having 2 D flip-flops. Okay, so for D flip-flop A, what is the input I have to give is designed. For D second flip-flop, what is the input I have to give is designed here. Okay, so those are the connections given with the help of a simple clock pulse which is connecting all the things. Okay, design part is quite common for all the sequential circuit students. Okay, so first of all, you design the state diagram. From the state diagram, you design the collect the information from state diagram to the state table, and collect the information from state table to the K maps for simplification of inputs and output. Design output separately, and with the help of flip-flops of your choice, not only D flip-flop, you can select any flip-flop, but if you're selecting D flip-flop, we no need to go for a design table or transition table. That is the choice we have here. Okay, so by using D flip-flop, I'm trying to have this K map, and for the connections accordingly from your K map is given, students. Okay, this is about design of a sequence detector with the help of Mealy state diagram we have seen, students. Okay, so students, any